This is an interesting paper that looks actually at something quite technical. It says stop explaining black box machine learning models for high stakes decisions and use interpretable models instead. You will see as I read some of the text, I'm going to be brief, that it is being very technical about models that are very sophisticated ML models, but they are so opaque that you actually need a separate model to explain the results that are coming out of this black box. And then you have simpler models that are interpretable so that you know why you got some of the results that you got. And the argument here, very forceful argument, is that using black boxes and thinking they are more accurate is actually not correct. Okay, so I'm going to be brief because mainly people like me, and there are many others who are not experts in AI, but we use AI in some form for downscaling climate predictions to farm scales or for flooding at city block scales and many other applications where we are making some choice that is not as deeply rooted in the knowledge of the AI as should be maybe, or we are just following other people's examples, or we are comparing multiple models and picking based on some metric and so on and so forth. Black box machine learning models are currently being used for high stakes decision making throughout society, causing problems in healthcare, criminal justice and other domains. So we'll look at some examples. Some people hope that creating methods for explaining these black box models will alleviate some of the problems, but trying to explain black box models rather than creating models that are interpretable in the first place is likely to perpetuate bad practice and can potentially cause great harm to society. So it's a dire warning there. The way forward is to design models that are inherently interpretable as opposed to black boxes that need to be explained. Explainable versus interpretable. This perspective clarifies the chasm between explaining black boxes using inherently interpretable models, outlines so this perspective clarifies the chasm between explaining black boxes and using inherently interpretable models, outlines several key reasons why explainable black boxes should be avoided in high stakes decisions, identifies challenges to interpretable machine learning, and provides several example applications where interpretable models could potentially replace black box models in criminal justice, healthcare and computer vision, meant in different domains, but we need to be aware of it for climate services as well, because we are going to be giving all sorts of advisories, early warnings and decision support tools based on ML for high stakes decisions on adaptation, mitigation, agriculture, water, health. Health care is mentioned here, which goes towards hospitals, insurance, etc., whereas health is actually about preventing disease outcomes, mitigate bad impacts of climate and so on and so forth, right? So let's see what is meant. Let's read some text. There's been an increasing trend in healthcare and criminal justice to leverage machine learning for high stakes prediction applications that deeply impact human lives. Many of the ML models are black boxes that do not explain their predictions in a way that humans can understand. The lack of transparency and accountability of predictive models can have and has already had severe consequences. There have been cases of people incorrectly denied parole, poor bail decisions leading to the release of dangerous criminals, ML-based pollution models stating that highly polluted air was safe to breathe, and generally poor use of limited valuable resources in criminal justice, medicine, energy reliability, finance, and in other domains. So pollution and energy apply to us as well. Rather than trying to create models that are inherently interpretable, there has been a recent explosion of work on explainable ML, where a second post hoc model is created to explain the first black box model. So you create a black box model, you don't understand what it's doing, it spits out some results, and then you have a second model that is run post facto to explain what results are being produced. Explanations are often not reliable and can be misleading, as we discussed below. If we instead use models that are inherently interpretable, they provide their own explanation which are faithful to what the model actually computes. So if you have an explainable explanation for a black box model and it's as good as the black box model, then it's the black box model itself. Obviously that cannot be the case. So explanation is essentially paraphrasing something, and you have to be sure that it is actually capturing the most salient information from the black box, because lives depend on it. Parole may be denied, or parole may be given to a dangerous criminal, and so on and so forth, right? So key issues with explainable ML, there are pros and cons of both. So black box model could be either a function that is too complicated for any human to comprehend, or a function that's proprietary. So businesses have a motivation, incentive to create black box models and say, we can't tell you what's inside, we'll just give you the results. And judges are using these kind of models to make decisions. Deep learning models, for instance, tend to be black boxes for the first kind, of the first kind, because they are highly recursive. As the term is presently used in its most common form, an explanation is a separate model that is supposed to replicate most of the behavior of a black box. For example, the black box says that people who have been delinquent on current credit cards are more likely to default on a new loan. Okay, new current credit, or not just credit cards. Note that the term explanation here refers to an understanding of how a model works, as opposed to an explanation of how the model works. Okay, understanding of how a model works as opposed to directly saying how the model actually works. The terminology explanation will be discussed later. It's misleading. I'm not going to read all the details. I'm concerned that the field of interpretability, explainability, comprehensibility, transparency in ML has strayed away from the needs of real problems. This field dates back to the early 1990s at least, and there are a huge number of papers on interpretable ML in various fields, and that often do not have the word interpretable or explainable in the title, as more recent papers do. Recent work on the explainability of black boxes rather than the interpretability of models contains and perpetuates critical misconceptions that have generally gone unnoticed, but that can have lasting negative impacts on the widespread use of ML models in society. So let's spend some time discussing this before discussing possible solutions. But as usual, I'm jumping text and just reading some of the most salient points, and I'm doing kind of a ML interpretation for you, because I'm taking a paper that's fairly detailed. I'm interpreting this in terms of most salient points according to me, so I'm explaining the paper to you rather than interpreting it. Wow, I'm getting too fancy, but generally there is a belief that the learning performance or accuracy drops off as effectiveness of explanations increases. So this is a fictional depiction of accuracy interpretability trade-off, which is actually a false interpretation or false trade-off. That's the argument of the author. It's a myth that there is necessarily a trade-off between accuracy and interpretability. There's a widespread belief that more complex models are more accurate, meaning that a complicated black box is necessary for top predictive performance. However, this is often not true, particularly when data are structured with a good presentation in terms of naturally meaningful features. When considering problems that have structured data with meaningful features, there is often no significant difference in the performance between the more complex classifiers, so deep neural networks, boosted decision trees, random forests, and so on, and much simpler classifiers such as logistics regression and decision lists. And this is after pre-processing for structured data. In data science problems where structured data with meaningful features are constructed as part of the data science process, there tends to be little difference between algorithms, assuming that the data scientist follows a standard process of knowledge discovery, such as KDD, CRISP, DM, and or big data, and you can follow up on the references for the details on that. Okay, so jumping ahead to the end of that section, to our knowledge, all recent review and commentary articles on this topic to our knowledge, all recent review and commentary articles on this topic imply implicitly or explicitly that the trade-off between interpretability and accuracy generally occurs. It could be possible that there are application domains where a complete black box is required for a high-stakes decision. As of yet, I have not encountered such an application, despite having worked on numerous applications in healthcare and criminal justice, energy reliability, and financial risk assessment. So the author is basically saying, I have done a gamut of problems and I have not found any such trade-off between accuracy and interpretability. Okay, explainable ML methods provide explanations that are not faithful to what the original model computes. This is an issue because if you use a black box model and use an explainer model and that's not accurate, then you are basically likely to make mistakes on what is being produced as a result and what decisions are made based on that false explanation. Explanations must be wrong. They cannot have perfect fidelity with respect to the original model. If the explanation was completely faithful to what the original model computes, the explanation would equal the original model itself, and one would not need the original model in the first place, only the explanation. In other words, this is a case where the original model would be interpretable. Right? The interpretable model doesn't need an explanation, it's directly interpretable. If a black box model is completely explained by an explainer model, then why need a black box model in the first place? This leads to the danger that any explanation method for a black box model can be inaccurate representation of the original model in parts of the feature space, as we'll see some examples. Just to jump ahead, an easy fix to this problem is to change the terminology. I won't go into the details here. So basically, rather than producing explanations that are faithful to the original model, they show the trends in how predictions are related to the features, calling these summaries of predictions, summary statistics, or trends, rather than explanations would be less misleading. So you can instead of saying this is an explanation of the black box model, you say it's summaries of predictions, summary statistics, trends, rather than explanations, and then people know that you are getting some product that is interpreting things for you. So it's explanation, but interpreting the model, I don't know. Okay, explanations often do not make sense or do not provide enough detail to understand what the black box is doing, and this can be obviously problematic. So we will look at one example of how image is being processed by a black box. So that's figure 2. Let's jump ahead here. Saliency does not explain anything except where the network is looking. In other words, you are using a black box model on a test image, so explanations using attention maps. So evidence for animal being a Siberian husky, so you can see that that's one interpretation. Evidence for the animal being a transitive flute. The saliency maps are used to say this is how the interpretation came about, explanation. But saliency does not explain anything except where the network is looking as it's doing this black box thing. We have no idea why this image is labeled as either a dog or a musical instrument when considering only saliency maps. Explanation, so saliency maps in this case is an explanation. The explanations look essentially the same for both classes. You can see that here. So there is other machine learning models as examples. Typically you have if else kind of statements. Age, range 18 to 20s, sex is male, age between 21 to 23, 2 to 3 prior offers. So essentially it's saying such a simple, explicit, understandable model can replace a model that is created to deal with certain real life issues like who gets a bail, who doesn't get a bail, and so on. It's called Compass, let's say. Black box, So it's not even an ML model, it's a data-based model which uses a lot of historical data on repeat offenders and race, etc., to decide based on history whether that person should get a bail or not. So 130 plus factors are involved. It might include socioeconomic info, expensive to license, and within software used in the justice system. Whereas Correll's model that we looked at here is a full model, as in table 1, only age, priors, and gender, and that too optional, no other information. It's free and transparent. So if it's a proprietary software that needs to be licensed, that's expensive, then justice system may think maybe that is more reliable, more accurate, and so on and so forth. Okay, so these are really tricky things that we also have to worry about when we offer advisories on climate services based on data, forecasts, combining them, downscaling them, and deciding which AI model works best. Key issues with interpretable ML. There are many cases where black boxes with explanations are preferred over interpretable models, even for high-stakes decisions. However, for most applications, I am hopeful that there are ways around some of these problems, whether they are computational problems or problems with training of researchers and availability of code. The first problem, however, is currently a major obstacle in the sense that interpretable model is something that may need to be built for each case, whether finance, air pollution, for justice system, and so on and so forth, in which case experts may have to be involved as opposed to a black box that just takes the data and does everything without experts being involved. So computationally it can be expensive and so on and so forth. But corporations can make profits from the intellectual property afforded to a black box. So companies that charge for individual predictions could find their profits obliterated if an interpretable model were used instead. So they have strong incentive to prevent interpretable models which are open and transparent from being accepted by US justice system, which is using the black box model Compass. Okay, so you get the idea. Just try to get the main points. Interpretable models can entail significant effort to construct in terms of both computation and domain expertise. So that's what I just said. So they can be expensive, and that can be used as a justification to use black box model and say that and claim that they are more accurate, even though nobody understands it. And then an explanation is provided as a post-processing of the black box output. Black box models seem to uncover hidden patterns. The fact that many scientists have difficulty constructing interpretable models may be fueling the belief that black boxes have the ability to uncover subtle hidden patterns in the data about which the user was not previously aware. A transparent model may be able to uncover these same patterns if the pattern is in the data was important if the pattern in the data was important enough that a black box model could leverage it to obtain better predictions, an interpretable model might also locate the same pattern and use it. Again, this depends on ML researchers' ability to create accurate yet interpretable models. The researcher needs to create a model that has the capability of uncovering the types of pattern that the user would find interpretable, but also the model needs to be flexible enough to fit the data accurately. This and the optimization challenges discussed above, which I skipped some of it, are where the difficulty lies with constructing interpretable models. So interpretable models are preferred, but there are some issues to deal with first. Encouraging responsible ML governance, there are some ideas proposed as to how actually governments like the European Union can impose policies or implement policies, let's say, to motivate ML governance where black box models are not seen as the most accurate for no reason, that interpretable models are also incentivized when necessary. Okay, so algorithmic challenges in interpretable ML, I'm going to skip that as well. So there are several challenges, but interpretability is basically domain specific. So what interpretable model works in the justice system will not be the same for air quality or for the financial risk system and so on, or healthcare for that matter. So you have to be aware of that, in the sense each domain may require expertise, which obviously makes dependence of the model on experts, and then it can get expensive in that sense. Okay, and then some ways are proposed there. So this is another example of how image from an available image indicating different parts of the bird are used here to create heat maps and showing which part of the bird is being shown. You can see little lines there. So this goes to make the point that the black box models can do something that can be, as we said before, a husky or a flute. So you have to be careful what is what the black box is doing. Here the image is predicted to be a clay-colored sparrow. The top prototype seems to be comparing the bird's head to the prototypical head of a clay-colored sparrow. The second prototype considers the throat of the, so you're looking at the different prototypes here. The throat of the bird. The third looks at feathers, and the last seems to consider abdomen and legs. So this is how you would use ML in different settings with different details. Discussions on interpretability for specific domains, just a little piece there. Let's finish this short discussion on challenges to interpretability for specific domains by mentioning that there are vast numbers of papers that have imbued interpretability in their methodology. Interpretability is not mentioned in the titles of these papers, and often not in the body of the text either in an explicit sense. This is why it's almost impossible to create a review article on interpretability in ML or statistics without missing the overwhelming majority of it, because if you do search meta-analysis, then you're not going to catch those papers. Okay, technical reason why accurate interpretable models that might exist in interpretable models might exist in many domains. Why is it that accurate interpretable models could possibly exist in so many different domains? Is it really possible that many aspects of nature have simple truths that are waiting to be discovered by ML? Although that would be intriguing, I will not make this kind of a Occam's razor style argument in favor of a technical argument about function classes, and in particular Rashomon sets. I won't go into the details there, but you can follow up on what the technical reason is for having potentially many accurate interpretable models in different domains, so that black boxes are not really needed in most cases. Okay. Just jumping ahead to the conclusion, not jumping to conclusion. If this commentary can shift the focus even slightly from the basic assumption that underlying most work in explainable ML, which is that black box is necessary for accurate predictions, we will have considered this document a success. If this document can encourage policymakers not to accept black box models without significant attempts to interpret the models rather than explain them, that would even be better. If we can make people aware of the current challenges right now in interpretable ML, it will allow policymakers the mechanism to demand that more effort should be made in ensuring safety and trust in our ML models for high stakes decisions. So obviously someone will have to think about this for climate applications, climate service applications. I'm just taking this because I feel that this is also very relevant for us, and of course the air pollution example is mentioned, which is obviously relevant to us. If we do not succeed at these efforts, it's possible that black box models will continue to be permitted when it's not safe to use them. Because the definition of what constitutes a viable explanation is unclear, even strong regulations such as the right to explanation can be undermined with less than satisfactory explanations. Furthermore, there will continue to be problems combining black box model predictions with information outside the database and continued miscalculation of black box model inputs. This may continue to lead to poor decisions throughout our criminal justice system, incorrect safety guidance for air quality disasters, our domain, incomprehensible loan decisions, and other widespread societal problems, climate change being one, adaptation, mitigation, food, water, energy, health, buildings, infrastructure, transportation, etc., are all our problems. And we are talking about applying ML models to make decisions for near term and longer term, and obviously we need to be aware of black box models versus interpretable models. Okay, so let's leave this here. I hope the podcast makes sense because I find it to be something to think about. Okay, so let's meet in the next topic.